Okay, I'm just going to run through the various rules for angles in circles. So this is called circle theorem. What I suggest you do is print off this first slide. You can take a screenshot of this video, or if I have sent you a copy of the PowerPoint, then I suggest you keep this as a way of revision. So these are all the different rules for angles and circles, and I'm just going to talk through each one. So the first one says the angle at the centre is twice the angle at the edge of the circumference. So if we've got a circle here, and here's the centre of the circle, and I have two radii, so radius, and this is subtended chord. So subtended is like ping, a little line that goes to the edge. The angle that's at the centre of the circle, so underneath the arrow, is going to be twice the size as the angle at the top. So if this angle x is 30 degrees, this angle here at the centre is going to be 60 degrees. And sometimes we are given the angle above this. You have to be very careful on this theorem. So check which angle you've been given. Remember, it's the angle underneath this bit that's twice the angle up here. So if we're given this angle around here to be, say, 100 degrees, which obviously it isn't because you can see this is bigger than 100. No, we'll say 300 degrees. So if this is 300 degrees, this would be 60 degrees to make a circle, and so x would be 30. So the next theory is angle in a semicircle is always 90 degrees. So again, if we have a circle, and here's the centre, and we have a semicircle, you can see that a semicircle, the line across the centre is the diameter, and it's a very similar rule to the previous one, where if you have two lines subtended that meet, then this will form a 90-degree angle. So x will be 90 because the angle underneath is 180. So the angle at the centre is 180, so this will be half the size. But this is its own rule because the angle in a semicircle, so half a circle, when the lines are subtended, you get a 90-degree angle. The next one, angles subtended from a chord are equal. So if we have a chord, so a little bit like a diameter, but it's dropped down. So this doesn't go through the centre of a circle. A chord is a line that goes from one side of a circle to another, but it doesn't necessarily go through the middle. And then if we have two lines subtended, so subtend means stretch. If we stretch this, then the angle subtended from the same bit will be equal. So if I did the same thing here, so a line going up and down, a line going up and down, it could go anywhere on the circle, but wherever it meets the edge of the circle, those lines will be exactly the same, those angles. So if this angle here is 45, this will also be 45. Sometimes this looks like a butterfly. You don't always see this line here, so you get this butterfly effect, and that's how you can recognise this one. So because we have that X shape here in the middle, the angles are vertically opposite, so these angles are also the same, which means that this angle here and this angle here are also the same. So this means that these two triangles here are identical. Okay, the next one, opposite angles in a cyclic quadrilateral add up to 180. So quadrilateral is a four-sided shape. Cyclic quadrilateral means four-sided shape within a circle. And it's the opposite angles that will add up to 180 degrees. They're not identical, they just add up to 180. So A and C would add up to 180, and B and D also add up to 180. but they could all be different sizes. Okay, the next rule is a radius and a tangent always meet at 90 degrees. So we know what a radius looks like. Radius is the line that goes from the centre to the edge. It can be anywhere on the inside the circle as long as it goes from the centre to the edge. And a tangent is a line that meets the radius and just skims the edge of the circle, and it kind of makes a T shape, so T for tangent, and that angle there is always going to be 90 degrees. It doesn't matter where that is on the circle, it will always meet the radius at 90 degrees. Okay, our next one is the lengths of two tangents. So we just discussed what a tangent looks like. But where the two tangents meet, they will form a point that's equal. So if we have a look here, okay, so here's the centre of the circle and we have a point outside the circle. If I had a tangent, so a tangent would be skimming the edge of the circle. We can't see the radius there. Okay, but a tangent is a line that runs from the outside. If we had a similar tangent the other way, then where they meet the radius, those lengths there would be exactly the same. We know that this angle here is 90 degrees, so this is also 90. So what actually you've got here are two identical triangles. The next one, angle between the tangent and a chord is equal to the angle in the alternate segment. So this is a little theory on its own. It used to be classed as the A-star question. We have a circle. Okay, we have a tangent. Here's a chord. And if we make that into a triangle in the middle, okay, so the angle between the tangent and a chord is equal to the angle in the alternate segment. Okay, so here is the tangent and here is the chord. Okay, there's an angle there. That's the same as that one there. And this is the one I was just pointing to. The angle between the tangent and the chord is equal to the angle in the alternate segment. So segment, this is a segment, and so this is a alternate segment, and that bit is going to be equal. Okay. One last thing to remember, it's not a rule on itself, but just remember that two radii make an isosceles triangle. Okay, so if you have a radius anywhere on the circle, if you join them up with a chord, then you would always get an isosceles triangle. You need to recognise these in questions. So again, this is the sheet that I first showed you, and you do have a mathswatch homework set on circle theorem, and what I've done, I've included which questions match up to the mathswatch homework. Okay, the ones in grey means it's not entirely obvious that this is the theorem to use, but the ones in black are, you would definitely use this rule. So the ones in grey, you might also need to use one of the other theorems. Let's have a look. I think there's one here that there's question 18 uses the alternate theorem segment, and the angles in a semicircle is 90 degrees. So I hope that helps.